with a coefficient of 1. The following. I'm going to write several terms together. Maybe we'll start with 2. Let's write 2 terms together, and I want to try to combine them in some way. So let's say I have 1/4 times the base 3 log of x minus the base 3 log of 3 plus x squared. What do we do with this? Well, remember one of our properties of logs says that if you have the log of x to some power, that's equal to having the power on the outside. It's an equals sign in that property. It can go back and forth. This 1/4 can go inside our logarithm by becoming a power. This is exactly the same as the base 3 log of x to the 1/4. And we can leave our second term alone for now. And I want to combine these 2 logarithm terms into just one, but we have a rule for this too. Remember that if we have, this was property 2, the log of p minus the log of q is the log of p divided by q. Here I have the log of this term minus the log of this term. All I have to do is divide them. I get the base 3 log of x to the 1/4 divided by 3 plus x squared. All these things are equal to each other. This is what we do if we want to write it in just one expression. Let's switch to one that goes in the opposite direction. Let's expand the following. Expand the natural log. I'm going to switch to natural logs instead of writing log base b every time. If I write ln, we all know what we're talking about. We all know we're talking about log base e. I should also note briefly before looking at this problem, if you just see log with no base, what does that mean? Your calculator has a button called log, has a button called log. There's no base on it. What your calculator almost certainly means is the base 10 log. Base 10 is the most common thing that we see, especially before calculus. So if you just write log, it means base 10. I will also tell you to be very careful if you use computers. Because to many mathematicians, when we write log, when we write log, what we mean is, well, which one do you think we mean? If you don't specify which log, we mean, of course, the most natural one. We mean the natural log. It sounds strange, perhaps, but this is what it often means. So sometimes on computer systems, log means log base e. Sometimes it means log base 10. Always be careful and check if you use such a thing. Your calculator is almost certainly, when it says log, means the base 10 log. Now I am going to actually use natural log, and I'm going to write it the way our books do, ln, and I want to find the natural log of x cubed times the square root of 4x plus 3, all divided by the quantity 5x plus 4 to the 7th power. So this whole messy fraction is trapped inside my logarithm, and I want to somehow find logarithms, find a way to use logarithms to expand this out. Well, let's see, I have the log of something times something. You see the multiple sign here. We know what to do with those. We have the logarithm of something divided by something, and we know what to do with that. So by using properties 1 and 2 that we came up with earlier, I can immediately rewrite this entire thing. This becomes the natural log of x cubed plus the natural log of the square root of 4x plus 3. My last term is divided, so I'll subtract off the natural log of 5x plus 4 to the 7th power. I've expanded, but I haven't expanded as far as I can. I want to get the powers out too. We don't need powers inside of logarithms. We have a rule to deal with those. That's why we came up with property 3. If I have the natural log of x cubed, remember the 3 pops out in front. I have 3 times the natural log of x. What about the square root? It doesn't look like a power, but if we think hard, we'll remember, yes, in fact, taking the square root is the same as saying to the power of 1/2. Remember that? Can you picture this as all this raised to the power of 1/2? If you can, you'll believe this must be 1/2 times the natural log of 4x plus 3. Here again I have a power. My power of 7 can come up front. 7 times the natural log of 5x plus 4. It's another way of writing the same thing, but it's all expanded out. I will tell you for the rest of your mathematical education, when you learn calculus, when you learn higher mathematics, when you do logarithms in biology class, and chemistry class, and physics class, and geography class, the Richter scale is built on logarithms. They're all over geology class. It will sometimes be useful to expand them out. It will sometimes be useful to put them together. We need to be comfortable with both. So what can we do with our properties? We can expand and we can simplify logarithms. It would be nice to do something more. Wouldn't it be nice just to solve an equation? Let's solve the following. Let's solve 4 to the power of 5x plus 2 is equal to, and maybe we can think of something not too hard for us to deal with here. Let's say this whole thing should be 16,384. Then we find what to do here. Well, it turns out we have several options for what to do here. The easiest one probably is just to, what happens? What if you fall asleep in class? Everyone looks at you and you've just woken up. Logarithm. Take logarithms of both sides is what you cry. So let's do that. Let's take the base 10 log of both sides. The base 10 log of 4 to the 5x plus 2 is the base 10 log of 16,384. I can now rewrite this. 5x plus 2 was in my exponent, so it's going to go out in front of my log. This is the same as saying 5x plus 2 becomes the base 10 log of 4, and this whole thing should be equal to the base 10 log of 16,384. I really want to solve for x, so it looks like I'll have to divide both sides here. 5x plus 2 is what used to be on my right side, the base 10 log of this big number. And now I'm sort of wishing I'd chosen a smaller one, divided by the base 10 log of 4. At this point, be very, very careful. At this point, you will be tempted to look at this fraction and to cross out the logs. You must never do so. It's absolutely forbidden. The log of something divided by the something divided by the log of something else is not simply those two things divided by each other. Remember how much work we've been through coming up with these properties? Remember how things don't work like that? The log of p times q is not the log of p times the log of q. It's very different. Every time you multiply, every time you divide, every time you add logarithms, pause and check what you're doing. The single reason most of my students lose points on quizzes on studying logarithms is they're not careful about this. Be careful about this and do not simplify here. But we can finish now. I can subtract 2 from both sides. I can divide by x. X should be all of this thing I've had before. Minus 2. All divided by 5. This is really ugly, of course. And if you plug it into your calculator and ask what it equals to, I think, at least if I did this correct, you'll find that x is exactly equal to 1. And I apologize if it's not, double check to make sure, but certainly this is the correct expression. Let's go back to what we had earlier when we started this thing. What else might we have done? Well, instead of taking the base 10 log, maybe it would have been nicer to take the base 4 log. After all, this is 4 raised to some power. And I know that the whole purpose of the base 4 log is to undo this idea of 4 to some power. Would that have made more sense? More generally, how do we switch between bases of logarithms? It turns out it's not too hard for us to do this, and let's make this the final thing we look at today. Let's learn to change bases. You might see a question like this. How do we express the base 2 log of 8 as a base 10 logarithm? The base 2 log of 8 must be the base 10 log of something. What could that something be? That's the last thing we have to learn. So let's try it. This is what I want to play with, this base 2 log of 8, and it might be easiest, therefore, just to name it. Let's call it x. If x is the base 2 log of 8, then what? Well, we know how to change logarithmic expressions into exponential expressions. We're better at exponents anyway, so let's make this 2 to the power of x equals 8. And now that I have this, I can introduce my base 10 logs. Let's just take the base 10 log of both sides. The base 10 log of the left side, 2 to the x, must be the base 10 log of the right side, 8. But now, hopefully, whenever you see something raised to a power inside a log, you sort of want to pull it out. We know we can do this by property 3, so the base 10 log of 2 times x is the base 10 log of 8. I can now divide, find simply that x is equal to the base 10 log of 8 divided by the base 10 log of 2. Of course, it's possible to simplify this. I mean, it's possible to get a number and find out what this is equal to, but we needn't necessarily. If we need to write this in terms of base 10 logs, we can. And in fact, this way of changing from base 2 log to base 10 log can be generalized much farther. We can do this for all bases at once. This will be useful for us in what's to come, so let's talk about it now. In general, if we have the log base A of x, that's always equal to the log base B of x divided by the log base B of A. Now you can use any B you want here. The base A log of x, the base B log of x divided by the base B log of A. And in particular, we have one that's going to be quite nice for us. If I ever have the base A log of x and I want to figure out what it is, it's always equal to the natural log of x divided by the natural log of A. All I have to do is let my base here be E. Remember, the base B log is the natural log. The base E log is the natural log. This is an expression that's very easy to type into our calculators and is often a fast way of finding things. Try it now. If I give you the base 7 log of 50, you can't punch that into your calculators, but you can look at the base, you can look at the natural log of 50 divided by the natural log of 7, and if you do this, I think you'll find something a little more than 2. Double check to make sure that your calculator can do this easily. Expanding logs, breaking them into pieces, using the properties to solve things and change bases. We're now building up our set of tools and are getting ready to move forward and to solve ever more interesting and more difficult problems. Thank you.